Hello, welcome. I'm going to be talking about the normal distribution, basically just kind of experimenting with some of the parameters. This is an interactive graph, so one of the uh, one of the benefits of having something like this is like actually being able to experiment with the parameters and see like how the shape of the distribution changes and whatnot. So here I've got like the mean and then the standard deviation. If we set it to 0 and 1, we've got something called the standard normal distribution, which is it's used heavily in statistics. Now, if we were to like change the mean to the right, you could see that it shifts. Okay. And you could see kind of this probability here underneath here, right? So it's basically kind of saying that there's more negative values that are likely to occur. If we were to do the same thing, we could see that here on the right. Now, if I was to increase the standard deviation, you could see how the tails kind of increase here, where what basically this means is that the density, the area under the curve gets larger, meaning that these unlikely outcomes are more likely to occur. That's where we get that term fat tails, right? Like fat tail distributions. Um, Stock market returns are fat tail distributions, right? I mean, like usually it behaves like certain times stock market prices behave in a range, but then there are times when the stock price could increase exponentially. And those are kind of those more rare events, right? So if you have these bigger tails, these fatter tails, basically what that means is that these unlikely events are more likely to occur. Okay. Whereas if it flattens out, it's less likely. The the mass underneath the tail becomes less. Thank you very much.